Okay, so last lesson you were looking at percent, and a lot of the stuff you were doing sort of related to that hundreds chart. Today we're going to look at breaking down percent, also using it for estimation, also using the algorithm, and some algebraic stuff as well. So a lot of different things that sort of come up with the same concept, but it's always good to have a multiple ideas in your toolbox because one might be more practical to use than others. So I'm going to show you a bunch of stuff. And remember, you can always pause, you can go back. I tried to relate a lot of these examples to the types of questions that you're going to have after this. So we'll see where it goes, okay? All right, so we're going to start with finding 20% of the number 25. By now, you should know that of means multiply, right? So we're going to remember that when it comes to dealing with the algorithm. But for now, we're just going to look at sort of relating your percentage in terms of breaking things down. So if I know that I want to find 20% of 25, I know that 100% of 25 is 25, because that's the full 100%. Which means that if I come in and I take off one of these zeros, right? I can't do dashes on there, so I'm sorry. If I want to do that, now I want to find 10%. It means that I'm dividing by 10, right? So 100 to get down to 10, I'm dividing by 10. So I'm going to do the same over here. I can't take off a 0, so I'm just going to bring in my decimal, right? So 10% of 25 is 2.5. And that would then also mean that if I divide that by 10, I get 1% of 25 would then mean that I've got to come in by another decimal place, and I get 0.25. Okay, if I want to find 20% of 25, if I know that 10% here equals 2.5, then all I have to do, remember what you were doing with ratio, if 10% is 2.5, 20% means that I've multiplied by 2 on this side, so I'm going to multiply by 2 on that side. My pen's not calibrated very well. So 10 times 2 is 20, so 2.5 times 2 equals 5. So that means that 20% of the number 25 is 5. Another way that you could look at it is with the algorithm. So we're going to take a little line over here, okay, because I want to do another example below. What I can do is say I want to find 20% of 25, the number 25. And the first thing I'm going to do is I'm going to change my percent to a decimal. And that's stuff that was covered last year. And I think we've talked about it before in class as well, earlier. But 20% is basically 20 over 100. And remember that over bar means that you're dividing. So you're doing 20 divided by 100. Well, 20 divided by 100 is 0.2, right? And remember the pattern. I have 2 zeros down here. So I'm just going to take my decimal, which in a whole number is at the very end of the number. And I'm going to go 2 to the left because I'm dividing by a whole number. So I'm going to go 2 to the left, so 0.2. And then remember of, and I know I'm making a mess out of this, of means multiply, okay? Remember that. If you remember nothing else I've taught you this year, remember that of means multiply. You're going to need that. So now I have 0.2 multiplied by 25. So then I multiply it through and I get 5. So notice how these two are the same. Okay, this method, really handy if you have a calculator. This method is really handy if you have kind of what we like to call round numbers that you can easily, like 2.5, you can do 2.5 plus 2.5. Most of us can do that in our heads. But imagine if you're finding 20% of 16.285 or something really a lot more complex. The algorithm's the way to go, okay? So I'm going to give you another example. So we've got 52% of 93. So going back to this first method, I know that 100% is 93. Okay. I also know that 50% would be half of that number. So 93 divided by 2 is 46.5. Okay. So remember, if it's proportionate or proportional, this is like a ratio. So if I divide this side by 2, I'm going to divide that side by 2. Okay. If I want to go and find, say, 10%, I'm going to go back to this 100%. But now I'm going to divide by 10, right? Because to get from 100 down to 10, I divide by 10. So I'm going to do the same on this side. 93 divided by 10 is 9.3. And then if I want to bring it all the way down to 1%, I'm going to further divide it by another 10, right? So I get 0.93. In order to find 52%, I can use 50%, right? And then I can use two values of this 1%. 52% equals 50 plus 1 plus 1. Yes. So I know that that 50% is 46.5. The 1% is down at the bottom there, 0.93. And 0.93 again. And I get a value of 48.36. Okay, and then if I want to come in and I want to check this with my algorithm, I'm going to find 52% of, remember it means multiply, 93. So I'm going to change that to, whoops, my pen's not working for me today. 52%, I'm going to divide by 100 because I want to change it to a decimal. So I've got 0.52. I'm going to multiply it by 93. Okay. And then once I multiply it out, I get 48.36. Okay. So we're going to go to the next example. The reason why breaking this stuff down works would be, as I said, when you're kind of dealing with what we call friendly numbers, numbers that are easy to break down. Also in estimation, so real world math, you're going to be walking into a store and you may not want to have to bring out your phone, okay? So some real world math. Now we all go shopping and your HST is harmonized sales tax. PST is provincial sales tax, so that's whatever we send to the provincial government. And then we also have GST, which is goods and service tax. So anytime somebody provides a service to you, a company provides a service to you, you get taxed on it. Anytime you get a goods, so some sort of item that like a, you know, any stuff that you buy for your house, any clothing that you buy, that's considered a good. Most food items do not have tax. But it is kind of broken down between confectionery versus, let's just call it real food. So if you go into the grocery store and you're buying produce and proteins and you know, your regular food, that's fine. But if you go into, say, Max or something like that and buy a bottle of pop and some chips, then you might find that there's tax added on top of that. Okay, anyway, I digress. So we're going to go out and we're going to buy a sweatshirt, okay? And that sweatshirt costs $34.99. Okay, and you want to make sure that you have enough money in your pocket in order to purchase it after tax. And I know some of you are looking at that going, that's no problem. But some of us do find that to be kind of tricky. So again, you just want to estimate to make sure that the cash that you have in hand is working for you. So the first thing that we're going to do is we're going to round. So we're going to take this to $35. Okay. Once you take it to $35, then we're going to start doing this percent breakdown. I know that 100% of $35 is 35. And I also know that 10% therefore is 3.5. Because remember, we're going to divide both sides by 10. Divide by 10. Divide by 10. If I want to get down to 1%, I'm going to further divide by 10, which means I'm going to bring my decimal over. So now I've got 0.35. Okay. The other thing that I could do is scrap this guy altogether, because now I'm getting into these crazy decimal numbers, and we're just in the realm of estimating. So maybe what I could do is just bring this down to 5%. So that means I'm going to cut that in half, which means 35 divided by 2 is 17, right? 17.5. So now I've got 1.75, okay? And what I can then do is say, okay, well, if tax is 13%, as I said, I just didn't write it down. Let's pretend we're going to round that as well. So the tax, we're going to round to 15%, because it's easier to just take 10% and then cut it in half than it is to take 3 of these guys and add them together. So I'm going to take 10% of 35, and I'm going to say, so this is 10 plus 5, right? My 10% is going to be 3.5, because we got that from over here. And I'm going to add that to my 5%, which is 1.75. Okay. And again, even if you want to, you can round this to $2. And you can call that $3.50. So now I've got $35 up here. $35 plus my $2 plus my $3.50. I can even call it $3 because I've done all this rounding up that I can round something down. But that's okay, we'll call it $3.50. So 35 plus 2 is 37. 37 plus 3 is 40. And then we've got that additional 50 cents. Woo! So you know it's going to be less because we've done a lot of rounding up. And this is also based on 15% as opposed to 13%. But at least this way, you know that you have enough money in your pocket, right? As long as you have 40 bucks, you're good. So let's go to the next little example here. All right. If I'm given a smaller percent of a number, and then I want to find out what that number actually was, you kind of have to work, you can actually do this in two different ways. So the way I showed you both ways on the slide share that I'm giving you with your homework. One came out of the textbook, but I kind of like putting in some algebra. And I find that if algebra is a strength of yours, but some other algorithms aren't, then go back to the algebra because it makes a lot of sense. So we've got to find 100% of a number based on a part that we're given. Okay, so if I need to find 85%, or no, I'm not finding it, but I know that 85% of a number is 17. Okay. What the textbook sort of looks at is breaking this down so that you bring this back down to 1%. Okay, so if I want to get from 85 down to 1, I know I'm going to have to divide by 85. And again, this is a proportion. So to get from 85 down to 1%, I divide by 85. So I'm going to do 17 divided by 85 as well. Okay, so 17 divided by 85. Now remember, we're dealing with decimals, and remember that a lot of the times you may end up with decimal numbers. Don't be afraid of decimals, okay? So don't automatically do 85 divided by 17, because you know that you can't do that anymore. So 17 divided by 85 is 0.2. So what that means is 1% of our final number is 0.2, because if 85% is 17, then 1% is 0.2. And then all we have to do is come in and say, okay, well, 0.2 times 100 equals 20. Okay. Now, another way to look at this is, as I said, algebraically. So when you're dealing with things algebraically, you want to really look at that part to whole proportion. So I know I've got 85%, and this is my part, and this is my whole. So I'm going to relate it as a percent out of 100. Okay, so anytime that you have this percent thing, it's always going to be out of 100. So that's the easy side. And then what you're doing is you're looking at if 85% is 17, remember that this guy means is. So 80, that didn't look so good. This means is. So 85% is 17. 100% is, I don't know, right? So that's where we kind of bring in our variable and we start doing some algebra. Remember that? Yay. And as I told you, if you get into these kind of relationships, this is going to get you ready for high school because I've already stated a million times, I'm sure you're sick of hearing it from me, but that when you're in high school, you get a whole lot of fractions, whole lot of algebra, and a whole lot of integers. So in order to solve this, what we're going to do is something called cross multiplying. Let me get my little highlighter, and we're going to look at it this way. Cross multiplying means we're going to multiply that, and we're going to multiply that. So just like the word implies, cross multiplying means make a cross, multiply the numbers. Okay, so the first thing I'm going to do is do 85 times n. I'm going to do this the long way. Some of you can do it in your head, I know, 85 times n, but I'm just showing this in the longer step. And then I'm going to take 100 and I'm going to multiply it by 17. So 85 times n is 85n, because I have 85 groups of n, and I can't simplify that further. And 100 times 17 is 100 groups of 17. So it's 1, 7, 0, 0, right? We just add those two guys on at the end, or not add them, but kind of attach them on at the end. Now I have 85n equals 1700. So now that I've got those numbers together, I need to divide in order to get rid of them. So I'm going to divide both sides by 85. Okay. Whoops. 85 and 85 cancel each other out, so I'm left with n. And 1700 divided by 85 is 20. Okay. I think that's the only example I have. Oh, and we can just do, yeah, that's all I have for that one. So I think you do have some questions like that on your homework, so come back to this if you need to. Okay, so up until now we've been looking at sort of calculating a percent of a number or finding out what the full 100% of a number was based on a portion of it. Now what we want to look at is increases and decreases. And I don't just mean that this number has increased by 15%. What's the new number? That's more of a standard amount or a standard question where you just take 15% of the number and you add it on. If you had a 15% decrease of a number, you would take the number, find 15% of it, and then subtract it. So you have examples like that on the slide share. This I want to go more into depth with you to sort of explain if you have two values, so you know that a number is increased from this to that, and you have to find the percentage that it increased. So it's a little bit kind of, I don't want to say opposite, but it's a different different concept than when you're saying that something's increased by 15%. Now you're trying to figure out what the percentage increase is or decrease. So we're going to have a look at, say for instance you have stocks, right? So we have stocks that have increased from $1.85 per share to $2.50 per share. If you're hearing all these shaky noises, that's my dog. The first thing that you want to do is find the difference of the two numbers. Now, I know you know negatives, but when we're finding the difference, really what you want to know is just the distance between 250 and 185. So the easiest way to do that is to just subtract the larger number and the smaller number. So take 185 from 250. So always start with lead with the bigger number. And that's my dog snoring, believe it or not. Minus 185. Okay, 250 minus 185. And that's going to give us 65 cents, or 0.65. Okay, the next thing that we want to do is, and this is standard for increase and decrease, is we want to find the difference divided by, remember that bar means divided by the original amount. Okay, so our difference is 65 cents, and in this case go back to your question, because this doesn't necessarily tell you anything. So you know that it's gone from this to something else. So the from amount is your original amount. So the difference is going to be 0.65, and we're going to divide it by 185. Okay, and 0.65 divided by 185 is equal to 0.351 repeat. So we're going to say that it's approximately 0.35, or if I, times by 100, multiplied by 100, I'm going to go 2 to the right? I'm going to get 35% approximately. So the stocks have gained by 35%. Now, going to a decrease, we go to the store, want to buy a pair of pants, right? So pants are on sale. The original amount was $55, but now on sale, whoops, for $43. Okay, so we have to find what percent did you get off, right? Because they usually say, hey, it's up to 75% off or whatever. So remember, this almost completely lined up, right? We've got to find the difference. Find the difference. Okay, find the diff. So we're gonna, all we need is the difference between 55 and 43. So the easiest way to do that is larger take away smaller. So 55 minus 43 is 12. And then remember that now we want the difference over the original. Okay. In the case of the stocks, you will notice that, like we saw before, it started at 185, but the price is going up. In this case, it starts at 55 and the price is going down. But guess what? You're still dealing with that starting point and you're still dealing with the difference. Okay, so you don't have to do anything different with these two concepts. You just have to remember that it's always over the original. So our difference is $12 and our original, so our starting point was 55. So I'm going to do 12 over 55, or 12 divided by 55, right? And that's going to equal 0.218 something something something, and I'm going to round that to 0.22, and to get that back to a percent, I'm going to multiply by 100, so I'm going to get approximately 22%. Okay, so that means that those pants are roughly 22% off. Okay, so really always remember that you're dealing with a part to whole, and sort of line things up accordingly. So we've got one last thing to do. This comes from a Math Makes Sense textbook, grade 8 obviously, but it's the Alberta edition. So, and you can also see this book's pretty old. It's older than you. In 1990, the population of Calgary, Alberta was approximately 693,000. Whoops. I highlighted it in white. The population increased about 24% from 1990 to 2000. From 2000 to 2005, it increased by 11%. So what it's asking you is in 2000 about how many people lived in Calgary. So what we want to do is we want to look at the 1990, and you know I like to list stuff out, right? So 1990, we know it's 693,000. Okay. Population increased by 24%. So this isn't how much of a percentage increase is it. It's just saying that it's increased by that much amount. So we need to know what 24% of 693,000 is. So we're going to do 693,000. And we can use the algorithm, right? 24% equals 0.24. So I'm going to divide by 100. Now I don't have my math pre-calculated here, so this is going to take me a second. Got to do it on my calculator. So 693,000 multiplied by 0.24. So we know that 24% of 693,000 is 166,320. So now I know that in 2000, approximately, right? That's the year 2000. I want to take this amount that exists, 693,000, and I want to add this amount to it because that's my 24%, because it's an increase of that much more. Okay. Equals. And now we've got a total of 859,320. Okay. So this is A. I really hope I have enough room here. B. Okay. In 2005, how many people lived in Calgary? So we know that in 2000, we have 859,320. And then we also know that we're going to do an increase. So let me just rewrite this down here. We have to do an increase of approximately 11%. So 11% divided by 100 is 0.11. And that value equals 859,320 multiplied by 94,000. And this is giving me a decimal. Haha. So this is why we get this approximation thing, 525. 525.2. Now you and I both know that you can't have 0.2 of a person, so we're going to round down, okay? Remember, we have to kind of think about our creative rounding. So this is now our year 2005 is going to equal 859. So 859,000, that's a 5. 320 plus 94,000. 525. Okay. Plus. Okay, so we have a total of 953,845. Wow. Okay. So that's B, right? How many people lived in Calgary? So therefore, approximately 953,845 people lived in Calgary. So now we want the increase in population from 1990 to 2005 as a percent. Okay, so here's where our percent increase comes in. So I know that in 1990, I had 693,000 people. I also know, so this is for, all my green stuff is going to be C, and I might have to go to the next page. So we're going to try and figure this out before I calculate it. So 693,000, and we need to go up to 2005. So I've got to use those two pieces of information. I don't know how I'm going to remember that. Okay. Hang on. So we've got 693 and 953,845. Okay, so I'm going to do this, and we've got to express it as a percent of the 1990 population. So we're looking at a percent. What is the percentage increase between those two numbers? So I'm going to go in. Page. We'll stay with green. Okay, so the 1990 was 693 and then the 2005 was this 953845. Okay. And what it's asking is, what's the percentage jump? So remember, first thing we have to do, find the difference. So we're going to do 9, 5, 3, 8, 4, 5 minus 6, 9, 3, 0, 0, 0. And we're going to get 2, 6, 0, 8, 4, 5. And then in order to get that percentage, we have to do the difference over what? The original. Okay, so the original, remember, is this guy, because that's where it starts, and then we need the difference. Okay, so we're gonna do the difference is 2, 6, 0, 8, 4, 5, and we're going to divide that by our original amount. Which becomes 0.376 bloody bloody blah. And so we're going to say roughly that's 0.38. We're going to round a little bit, approximately. And then remember, got to multiply by 100. So it's going to equal 38% approximately. Now I'm going to go backwards for. It says, is your answer 35? No, it's not. Should it be 35? So it's asking, is the percentage increase 35%? So our increase is not 35%. Okay, and what it's saying is, should it be? The reason why it's asking that question is that from 1990 to 2000, I think it said, it increased. So 1990 to 2000, there was an increase of 24%. And then from 2000 to 2005, there was an increase of 11%. And if you take 24 and you add it to 11, you get 35. We got 38%. And the reason why it's not going to be 38% is why. So I don't want to tell you the answer, but I guess we have to do that. Originally what you're doing is you're finding 24% of an increase of a number. So we did a 24% increase of 693,000, and then we added it to get a new sum. But then what we found was 11% of that new number. So if we were looking for a 35% increase, we would have to take 24% of 693 and then add it to 11% of 693,000, right? That's the only way we would get 38%. But because we have added that 24% onto the original 693,000, then when we take an additional 11%, now we're finding 11% of a larger number instead of 11% of the original number. So hopefully that makes sense to you now that I explained it. Hopefully you can see it. Or some of you probably figured that out as I was rambling and thought, hey, wait a minute. And then you answered it before I did, which I would hope. So have a look again. Go back to these questions if you need to. I've tried to mirror them to the types of questions that I've assigned you. there isn't a whole lot of room for you to show work and whatnot, but you know, please make sure that you're sort of calculating things out. I am going to be doing a summative with you. I'm not going to be doing a test. You've got a big summative coming up, and I'm going to be looking for work on that. So if you can practice at least the work, you can plug in the numbers, but on your homework, anywhere it says to do an explanation, please do so, because that one I am going to be looking at myself. And I'm looking forward to giving you this summative because it's real world stuff, and it's kind of cool. It's all about what can you afford. So yeah, go have a look at your questions, and again, come back to this if you need to, or go back to the examples that are in with the questions. Happy calculating!